Welcome friends for the third video lecture of the digital circuits. In this video we are going to understand all of the basic logic gates by using the transistor. How basic logic gates can be formed using the transistor. In previous video we have understood that there's basic logic gates can be formed using the diode circuits and basic resistors. But in this session, we are getting some basic idea about the realization of this logic gates by using the transistors. How a transistor can be used for the operation of the transistor, operation of the basic logic gates. So for the operation of the basic logic gates, first of all we are going to understand the NOT gate using a transistor logic. Here we can see that the transistor logic can be used in this way for the NOT gate. What happens over here, that all the time whenever we talk about the transistor, there will be a condition where the supply voltage, that is input supply voltage, is basically of some value. So if we are talking the silicon transistor, then it could be greater than 0.7 volts at the input side to operate the transistor in any particular state. So here we are providing what kind of what amount of voltages at the input side that will decide the how a transistor will work. So that is the basic idea, and we also know that the transistor can be used by particular in two regions as an switch, that are saturation region and the cutoff region. Cutoff means we are setting at the off condition for the transistor, and saturation means we are setting the condition to switch on the transistor. Once in saturation region, we are very well knowing that the no output effect can be shown if any kind of change in the input will be there. So means on, that means output voltage is getting the at rated value. So for the first condition, we are just seeing that right now we are providing the zero input as we are realizing the NOT gate. So for the zero input, there will be the voltage which is below the 0.7, and hence the transistor will be in the off condition. Hence the whatever the biasing voltage will be at the output side, it will provide you the one output. And for the second condition, now we are providing the some input voltage, and in this condition we are getting the transistor in the on condition, and completely the current flow will be like this, and hence no output will be shown seen at the output terminus. So this is the basic realization of the NOT gate using the transistor. As we have discussed in the diode video, that NOT gate was not realized by using the diode. So we are realizing that NOT gate by using the transistor, and this way we can realize the NOT gate logic. So after that we are realizing the AND gate using the transistor. So this is the basic circuit diagram of the AND gate, and in this way there will be three transistors, and these transistors were getting some amount of voltages by providing different inputs at the input side. So for the very first case, we are taking the input in this way. So for the both the zero, we are knowing that the transistor should be remained in the cutoff condition. So for the cutoff condition, we are providing the zero input. So that means the earth, both the terminals are earth, and both the transistor will be in the off condition. Hence what happens, that Q3 will be in the on condition, and hence the flow of current will be in this way, and that means the output will be in the zero condition. That means no output will be there. as we know that the truth table, that all the output will be 0 and only one output. When both the inputs are 1, then and then only the output will be 1. So in this way we are saying both the conditions, both all the three conditions, these are 0 1, and after that 1 0. In both the conditions we are getting the 0. And right now, whenever we are turning on both the transistors, that are Q1 and Q2, the output will be the 1. So this is the basic realization using the transistor of an AND gate. So in this way we can represent the AND gate using the transistor, and we can realize this condition by using the 3 transistors and setting some input voltages. So the main funda is that if we want to switch on the transistor, then the applied voltage should be greater than the 0.7 volts. Otherwise the transistor will be in the off condition if the voltages are less than the 0.7. So realization of OR gate using transistor, what we are doing, this is the basic circuit diagram, see, and in this also we are using the 3 transistors, and all the 3 transistors will be on and off by turn, which is generally represented by giving some different inputs. So first of all we are giving both the inputs as 0, and the Q1 and Q2 will be in the off condition, but the Q3 will be in the on condition, and the current flow will be like this, as in the case of the previous AND gate transistor, AND gate logic circuit. So after that we are getting the different inputs for different outputs. This is the basic, that is 0 and 1, and the output will be 1. For this condition we are seeing that Q1 and Q2 both have different states. Q1 is in off condition and Q2 is in the on condition. As we can see that the plus 5 volt is over here and 0 voltage is over here, so hence the Q1 will be in the off condition and Q2 will be in the on condition, and it will provide you the output as 1. After that, for the third state, what we are doing now, we are providing the high input to the A terminal and 0 as the B terminal. So what happens now, that Q1 will be in the on condition and Q2 will be in the off condition, and certainly we will get the output as 1. And for the third output, both the inputs are 1 and hence the output will be 1. In this condition both the Q1 and Q2 are in the on condition and output will be 1. Here the third transistor will be in the off condition, less than the 0.7 volts will be there, because now what happens that completely the flow of current will be like this, in this way, and hence the output will be available at the output terminals. So that's all for the basic logic gates for the realization using the transistor. So in this way the transistor logic can be performed, and basic logic gates can also be performed using the transistor and as well as the diodes. So both the cases we have discussed, and hope you will get some brief idea about the transistor logic for the basic logic gates. Also we have seen the different universal gates by using the transistor and diode. Also both are responsible and both can be used to perform basic universal logic gates. So that's all for the video. I hope you all like the video, and thank you. Don't forget to subscribe my channel. Thank you.